Right. Okay. Um, the first thing, the first objective is we need to identify the scientific context of our engineering and the social context. Then we will look at what our engineering professionalism should include, what traits, what qualities. For an example, maybe we need to know about the technology or the science or the application, and maybe the skill of implementation, ethics, those kind of things we will discuss here. And then the other important thing is the non-technical aspects of engineering decision. Now, though it is called the non-technical aspects, actually it is not the non-technical engineering aspects. Some other techniques. For an example, let's imagine now we are going to manufacture a pen, ballpoint pen. Let's say it's a new innovation. There we have to take a call whether this to implement in society at large. In manufacturing, we need to look at the economic feasibility or the social or a cultural aspects. Those things also we are learning. So there are many tools, in fact, in economic side and the finance side. Those areas we need to cover under the objective 3. For an example, we need to look at maybe, let's say a project, we need to look at net present value of our cash flows, whether financially viable this. We need to look at if it is an investment, what is our return? We need to calculate it and see payback period of our investment, whether it is covering up by 3 years, 2 years, 5 years, 10 years, we need to look at. Or how are we going to make a decision on when the things are so complex? Those things we are going to discuss under objective 3. Then the fourth one, that is one of the very important area, the communication. No matter how knowledgeable you are, if you are unable to communicate properly, that may be a language, or in addition to that, actually language. So we have to have some communication skills. When you are in a team, how we are going to communicate? When you are in public, how we are going to communicate? When you are doing a presentation, how we are going to communicate? When you are writing a letter, how we are going to communicate? When you are writing an email, how we are going to communicate? All these matters. Just you can communicate something, but we have to look at whether the objective is fulfilled. We will look at that as well. Everybody clear? Hello?
Yes, sir.
Everybody clear? Right. Yeah, because now since this is actually the virtual, so I can't see all faces, right? So I don't know actually, so how much you understood or how much clear for you all, right? If you are giving feedback, it's always very important. It is easy for my job. Otherwise, so at the end of the year, only I will get to know that whether you all understood or not. So, I mean, then and there we will resolve the issue and will continue, right? So then we will cover up 3 sessions actually today. These are small things. In general introduction, we will look at the scientific context of engineering, and then we will look at the social context of engineering. Now, to start the lesson today, I want to tell you all about one important theory. This is called system theory. Anybody heard about this before? This is actually, I mean, these things are readily available in textbooks and even internet, right? So if you go and browse Google Scholars, you can find many articles. System theory. So this is the gentleman actually who introduced this theory, von Bertalanffy, Carl Ludwig von Bertalanffy. Any idea about this philosopher? This, I mean, which country this person belongs to? Have you all watched the movie The Sound of Music? If you all can remember the captain name, Von Trapp is an Austrian guy. So this gentleman also from Austria, the von Bertalanffy. Yeah, he is not actually the engineer. He's a biologist. He's an Austrian biologist. But this concept he introduces irrespective of the subject. So he identified all the subjects and everything in the universe as a system. What is a system? There are many definitions. This article, this is the reference of this article. I extracted a definition for a system. It says a system can be defined as an entity which is coherent whole, such that a boundary is perceived around it in order to distinguish internal and external element and to identify input and output relating to and emerging from the entity. Anybody got the idea? Right. If I tell you in simple terms, system has to be considered as something whole, something big, as everything. It has boundaries. From these boundaries, we can identify, so what are the elements inside the boundary? What are the elements outside the boundary? And what are the things coming out from the system inside the boundary? Then we can say the system theory, we can define the system theory, or we can discuss the system theory as a theoretical perspective that analyzes a phenomenon, a situation seen as a whole. I'm repeating that, everything as a one whole thing, not simply the sum of elementary parts. If I ask, what is the answer for 1 plus 1? Can anybody answer? What is the answer for 1 plus 1? Come on. Somebody?
2.
Sorry?
2.
2. Okay. So anybody having a different answer? Anybody having different answer?
No, sir.
Sorry?
No, sir.
No, right. Okay. It doesn't matter. So I really appreciate that you're responding, right? So 1 plus 1, yes, in mathematically, we say it is 2. But when it comes to system, 1 plus 1 may not be always 2. Sometimes it may be more than 2. Sometimes it may be less than 2 in a system. For an example, imagine in a let's say in a not a big garment factory, you take just a tailor shop. They are only imagine they are only making shirts and trousers, right? One is taking cloth and cutting, the other one is maybe putting stitches, and other one is packing. Let's say only 3 people. Now, if you put another 2 people, now the outcome, the output of the production, will it be double? Or, I mean, let's say another 3 people you put it. Will it be double? Always not. Sometimes it may double. Sometimes it may reduce also. Right? So that's the difference. I mean, the system may not always work the way we expect. So there are interconnections between the element inside the system. Right? There is a video actually you all will understand very clearly, right? So now the focus of an interaction and on the relationship between the parts in order to understand the entire organization functions and the outcomes. The focus is on the interaction. So we need to look at the interaction between the individual items in the system, and then we have to look at the system as whole, not individual. Now, the person who introduced this terminology, the system theory, so he defined the system as a complex interacting elements. He says system is a complex interaction elements. So Von Bertalanffy fosters system thinking in all disciplines in order to find a general principle valid to all systems. That is because basically now this Von Bertalanffy identified there are physicians, there are engineers, there are chemists, biologists. All they are working on different areas. But the Von Bertalanffy identified all they are working on systems. That is why he introduced this general system theory it's a new scientific paradigm contrasting analytical mechanical paradigm. So it explained everything. Is it now more confused or what? Hello? Got some way, or is it more confused now?
Clear, sir.
Right, okay. Now, this part, system theory, is a conceptual frame. I mean, we need to understand that it's a conceptual framework based on principle that component part of the system can be the best understood in the context of the relationship with each other. This is another definition. This is the first one is the Von Bertalanffy's original definition. The another definition is this. The system is a conceptual framework based on the principle that the component part of a system can be best understood in the context of the relationship each other. If you put it in a pictorial form, you can see this is the system. You have input, you have output, you have feedback. Now, there are 5 key concepts that we need to understand in the system theory. The one is the holism, The other one is interconnectedness, feedback loops, emergence, and boundaries. What do you mean by holism? As I explained earlier, the system must be understood as a whole, not just as parts. If you look at the tailor shop, the tailoring shop, we should not only look at the how many machines are there, how the machines working only. So we have to look at number of machines, their efficiencies, and the people and the environment, people who are working there. So everything matter, and with I mean each and every component of this system affect the other. So we have to look at the output, the whole thing. Got it? Then the other one is the interconnectedness. All parts of a system are interconnected, influence each other. Can anybody tell us an example for a system? Any volunteer? Example of system? We'll say a computer. Computer is a system. We have processors, we have screen, we have battery there, we have keyboard. So all are interconnected. If you take a human body, it's a system. In our human body, we have lungs, we have heart, we have urinary system, we have the digestive system, we have aspiration system, we have skin, we have bone. So all interconnected. If you want to raise your hand, just by having a hand, can you raise hand? No. You have to have a brain as well. You have to give that message. You have to have the muscles. If you want to just to see, can just see by having eye only? No. You have to have the brain also to identify that picture. Right? So there are enough things we can see as a system. Then the other one, the feedback loops. Here you have feedback to input, you have feedback to output. So what's the importance of having feedback? It gives sometimes the positive feedback, sometimes negative feedback. When you have the positive feedback, so whatever the change will amplify. If you get a negative feedback, so the system will be stabilizing. Let's take an example. Let's say now you're playing a game, right? You're playing badminton game. Let's say you are playing badminton game. Your coach is looking at you and he's telling, okay, when the shuttlecock comes to a good height, like just above your head, you better always smash if it is at half court. So then what will happen? So when you are playing, always when it comes, you can do that. It change your body system, and you take that action, and your repetition. So whenever you see the shuttlecock at that level, you will do the same thing. Imagine now somebody is very weak in playing smashes. That coach may say, look here, so how much we said, or how much we practice, you are weak in smashes, but you are very good in dropping and the placing. So that's a negative feedback. But what you do? So you stabilize rather smashing. So you stabilize, you balance your game, you stabilize your game by changing it to another action. So the systems are having feedback, that negative or a positive, whatever the feedback is, very important, and it is happening. Okay. Then the other thing, emergence. What do you mean by emergence? What comes? Outcomes. So the outcomes of the system in a computer program, the outcomes. And the system is having a boundary. Let's say now you let's say you have a line. So one of you all in this classroom is licking and tasting it. The person who lick it feel the lime taste. Correct? Who is that person? The person is a system. When somebody else is licking the lime taste, will I get that same taste? No, because I am a different system. I'm outside. Got my point? Got my point?
Yes, sir.
Right? Systems are always having boundaries. Yeah. Now, we will move to now. Okay. So what is the importance for us now? Why we are learning the system? What is crucial for us? It is crucial because all these engineering projects, all these engineering innovations, whatever that we are creating for the social, environmental, and technical society. So whatever the innovations comes to this society, the society is a system. The society is having social component. Society is having environmental component. Society is having technical component. So engineers must consider how these components interact and influence each other to design effective and sustainable solution. I will tell you a good example. Right? Now, our country population is about 22 million. Now, the Colombo, when it comes to Colombo, I can't exactly remember the land area, but this is one of the, the small area, but the population is so high. That means the density of population is so high. So the Colombo, there is a huge demand for the houses. The people who comes to urban living, they need houses. I'm telling this story. This is the true story. This happened somewhere around 2006, I guess. Right? Now, this requirement, this housing requirement identified by Urban Development Authority, UDA. Got it? This UDA wanted to get private sector to involve in constructing houses for the urban requirement. They got a land from public trustee. That is a 97-acre land in Piliand. It is a Regidale state. You know the owner of this land? This owner of this land is actually The person who wrote our national anthem, who wrote our national anthem? Nobody can remember. Yeah. Are you all with me?
Yes, sir.
Right. Now, this land actually.
Ananda Samara.
Yes, Ananda Samara. Right. This land actually, by the time now, when he died, he gifted this land to public trustee government. And he put a note saying that whatever the income coming from this land to be shared to the villagers, the young villagers who are newly married, to give some 25,000 rupees or something. Or the government can use this land for any of the other project. Now, the UDA identified this land is they are just remaining, so they wanted to have some project. Then they advertise through BOI, and the private sector gave proposals, and one of the company given the best proposal and the highest offer for the land, and they won it. Now, the construction of houses is an engineering project. Now, where this engineering project comes, that is in the system. What is the system? Our social system. In our social system, there are social component, there are environmental components, there are technical components. Technical side is how we are going to construct houses. It is like, I mean, let's say now the concrete, reinforced concrete structure, bricks, the masonry structure, so whatever it is. Now, what has happened with the political involvement, some of the political involvement and the social pressure, so they wanted to stop this project for their different motives, and finally they stopped the project. Now, look at, if we really think of only the technical aspects of engineering, so without any problem, we would have done this project. But what has happened? The society rejected this project. Not the whole society, but part of the society rejected. So, likewise, I mean, whatever we do, sometimes whether maybe a good thing or whether be a bad thing. Now what has happened to our MLT, lightweight railway project? That also stopped because of some political decision. We are working in society reacting, the individual component of the society reacting in a different way, and it impact in a different way. I'll tell you another story. Okay. Before we that, now we got the point. I guess all of you all got the point why it is important for us to know the system. Because we need to understand the society we are living is a system. There are different components. It has social aspects, it has environmental aspects, it has technical aspects. So all these parts interacting each other. So when we are doing some creation, when we are doing some innovations, engineering product, it impacts the society. So the society look at in a different angle. So we have to think of all these things before we doing anything. So the understanding system is very important. Earlier also we discussed this, the holistic approach. Now we'll look at little more in engineering side of this. You are supposed to design a transport system. What do you want to think when you are designing a transport system? So what aspects you need to think? Imagine you are designing a southern highway. So what aspects you need to consider? Is it just to consider only the road? No. You have to think of, when we are constructing the road, so what will happen to the environment? You have to think of, so how it affect the irrigation system, water disposal system, how it affects the flood, how it affects the animal. We all know that. I mean, when we are having an airport in a bird sanctuary, it's a problem, because that environmental impact to an airport will be crucial when there are a lot of birds are there, right? So likewise, I mean, we should not think of only the engineering creation. We have to look at the other aspects like environmental and the societal implication. Not only that, we have to look at the economic feasibility also. If you are doing a let's say the highway, just a southern highway, we have to look at how much we are spending, how much the return, and how long will it take for you to cover the cost, whether it is 15 years, whether it is 20 years. All these things we need to consider. Otherwise, if you just dump money, and if the return is not there, it is a waste. The other thing, interdisciplinary collaboration. In a system, we should understand interdisciplinary collaboration. What does it mean? Okay, I will tell you another good example, right? We were constructing a 40-story office building. It has 4 basements. That is in between the Indian Ocean and the Bere Lake. That is inside the land, the Western Province, right? Between Indian Ocean and the Bere Lake. When we are doing basements, we need to go about 25 meters below the ground level. We need to excavate. Are you all with me? Guys, are you all with me?
Yes, sir.
Yes, sir.
Right. Now, when we are doing this excavation, we can't, I mean, the 25 meters, if you multiply it by 3, 75 feet, right? Generally, the height of your, the single story house is minimum 10 feet. Imagine 75 feet, we are going down. For us to excavate in Colombo, we need to have a shoring system. Shoring system means, so we have to have some kind of a retaining system so that surrounding soil will not collapse, surrounding buildings will not collapse, there will not be any settlement surrounding area, and we should be able to excavate the things without any problem to the surrounding. So there is a mechanism called, there is a technique called the construction of secant pile. The secant piles, in fact, it is like this. If I if I draw secant piles, you are constructing piles like a ballpoint pen, right? You are constructing piles like this all around the building, right? You can see an intersection part, right? Because of this intersection, so this is outside, this is inside. You won't get any water or any soil into the excavation area. But you know what has happened during the design? During the design, the design engineer did not think about the hydrology side of the environment. Now, I said this building is like the shape, right? This side is Indian Ocean. This side is the Bere Lake. There is a flow, underground water flow from here to here, right? There is an underground flow. It's like a river under the ground. There is a water flow. Now what has happened? I mean, since we disturb the water flow, whenever there is any weak point between this concrete barrier, the water comes through this. Now, that we have realized actually, so once we are doing the excavation on, but what I want to tell you all, now this would have been identified earlier. We need to work along with other disciplinary scientists. We would have worked with actually hydrologists. We would have worked with geologists, not only the structural engineers. And we also would have been worked with sociologists to balance the situation. Any tense comes up. So we, in a system, we need to look at all these aspects, not just only the engineering. We have to work in collaboratively with other subjects. Then the other thing, I don't know whether you all can understand. Am I teaching correctly? Am I telling clear enough? Or am I talking too much? Any
clear.
feedback?
It's clear.
No,
Right.
sir, it's good.
Right. Okay. Now, system thinking. So, I mean, as we being engineers, we need to, I mean, we need to look at the whole thing. That is what it says. We need to think as a system. We never, in this building project, we never just think of constructing this building. We have to think of a society as a system, right? So that is it called the system thinking. Then the other one, the feedback mechanism, as I said earlier. So we need to get the feedback and we need to work accordingly. I will tell you another example, the feedback mechanism. Now, imagine you have a basement car park. In a basement car park, the car parks are to take the vehicles in. When vehicles comes in, when internal combustion engines are there, it emit CO2, carbon dioxide, and some other gases. Now, over a period, when there are a lot of vehicles comes and goes in the basement, so what will happen? CO2 concentration will go up. Correct? Now, we have to, when we are designing some system, the car park is a system. Now, when you are designing this car park system, You need to design the system so that you are getting the feedback. What is the feedback you need to get? One thing, you need to get the CO2 level. One thing, you need to get the feedback from the security point. They need the feedback whether the car park is full or not, whether there are empty slots. Right? If you look at this CO2 matter, so you can fix CO2 sensors. Then when the CO2 levels comes to a certain value, it is not favorable or good for health of people, then what can happen? Then that message can pass to a system, to another system, maybe exhaust fans. You extract the CO2 gas from one side, you get fresh air from another side. Likewise, whatever the system, you will have a feedback, right? The other thing, whenever you design something, it has to be sustainable. Your design should be sustainable, can withstand and adapt to a changing conditions. Any example? Look at our human body. Now, our human body is a system. We go to Nuvareli. Nuvareli temperature is maybe 5 degrees, 6 degrees, 7 degrees. So now our body, now we lived in Colombo, all of a sudden we went to Nuvareli. Now Nuvareli climate is different. Are we dying there? No. Our system is adapting to that environmental change. How? We will get shivering and we will burn more glucose and generate heat. If we go to a very hot country, so what will happen? So it creates sweat out, and when the sweat is evaporating, our body temperature goes down. Similarly, whatever the designs also, our designs also should be capable to, should be able to tolerate these changes. And the other point is the stakeholder involvements. What do you mean by stakeholders? Stakeholders are the people who are interested in this. So who are the stakeholders of your university? Who are the stakeholders of university? Your university. One is student. Student is one stakeholder. You like to know, so what is happening? You all are really interested, right? Other one may be the management, right? University lecturers. And there may be some other stakeholders, those who are living by selling certain things, the people who are giving transport service, right? All these people are stakeholders. Not only that, the government regulatory authority, the UGC is looking at and see whether this course criteria, the quality of this course, whether that is standard enough, right? So all these bodies are working on it. So that's why the UDA is there. For an example, so you can't just arbitrarily build anything in anywhere. There are regulations. When you are building a house, let's say, so you can't build the house in your total land. There is a floor area ratio defined, and the number of windows, the light. So there are regulatory authorities. We have to work along with all these bodies, right? So we should understand the society is a system. Okay. So far, is it clear? Is it clear? Right.
Yes, sir.
Yeah, before we move to, I will share a video. Right? It says, what is the system? This video, now this pronunciation is bit kind of difficult. Actually, not a Sri Lankan guy is pronouncing this. The narration. Can you all see the video still? Not, no? Can you all see or not?
No, sir.
Sorry? No.
No, sir.
Right. I think I have to share the I have to stop sharing this. Now can you all see?
Yes, sir.
Right. Now, this video is about the system theory, right? This is readily available actually in internet, right? Listen to this. I will put the subtitles actually that will be useful for you all to understand where the subtitles comes. Here. Subtitles, English. Yeah. Now, time to time, I will stop and I will explain just to understand what is system theory that has been introduced by this gentleman. Yeah. This video is done by actually one of the philosopher, Dr. Senek Moravik. He is the inventor of the artificial general intelligence. You all must be knowing already. Yeah.
Sir, can you share the sound as well?
Sound is not coming.
Yes, sir. No.
Why is it not?
From the Zoom, you have to share the sound as well.
Wait. Anybody can help me? Is it from, I have to click more?
In the share option, there's a, you have to tick a certain box to share the sound as well.
The share option.
Yeah, in the Zoom share option.
Share sound. Yeah. I'll repeat it.
Ludwig von Bertalanffy.
Can you all hear sound now?
Yes, sir.
I stop. Huh? Right. Okay. I'll play again. Right. So this pronunciation bit difficult, but I switch on the what do you call the subtitles, right? Nothing big here. Actually, what we need to understand is what is the system. That's it. Yeah.
Was an Austrian-born biologist that is known for his creation of general system theory, which for practical reasons I will call in this video only as system theory. Why have I decided to make video about Bertalanffy's system theory? I want to show that some things that he came up with are of enormous importance for understanding my own theories and also for understanding basic principles of universe. What Bertalanffy basically did when he created system theory is that he postulated that any section of universe around us that we perceive can be described as a system.
Got the point? What he's telling, the Bertalanffy is taking anything in the universe, he's saying can be described as a system. Anything in a universe can be perceived or can be explained or can be described as a system. Yeah.
Bertalanffy has not created the term system himself, but used it as general name for describing things independently of any particular scientific field. Please note that Bertalanffy did not create his system theory to understand universe. He just wanted to remove differences among scientists working in different scientific fields. So what I am presenting here from Bertalanffy's system theory is just compilation of his work. I have used only things that I consider relevant for my purposes. When you look on this first figure, you will see one big blue circle and several small circles inside this big blue circle. This is a diagram that shows how Bertalanffy's description of universe around us is working.
You got it? Now he is thinking this blue big circle is a system. He identified universe as a system. And then he identified there are components inside the system. These are the small different color circles.
The big blue circle is called system, and as such it may represent anything in our world. It may be a representation of human body, representation of one living cell, representation of electronic radio, representation of steam engine, representation of planet Earth, representation.
Is telling system can be a steam engine, system can be a computer, system can be a cell of a human body or anything. Yeah.
Of atom or molecule, etc. It can be representation of anything in this universe, and it is always just a section of universe. The small colorful circles inside the big blue circle are called subsystems and are part of the system that is represented by big blue circle. Bertalanffy's system theory postulates that any section of the universe can be called as a system, and that system is being represented by its subsystems. Subsystems make up for a structure of a system. So, for example, structure of human body as a system is specified by particular human organs as subsystems. Structure of a computer is specified by its memory modules, processor, buses, etc. These parts are all subsystems of a system called computer. Subsystems also interact with each other, which is being used to explain function of a system. For example, in a computer, the processor interacts with memory, and some of these interactions may be described as a function of a computer. So you see that interaction of subsystems can be used to generally describe function of any system in this world. On figure 1, the interaction among subsystems is shown by black arrows. Subsystems may also have interactions with other systems than this blue circle system on figure 1. Such interaction is shown by one arrow on left pointing outside blue circle towards system of higher order. Now, the interesting thing about system theory is that when you look on any particular subsystem closer, you will see that this subsystem is not finite element, but rather represents another system.
Here is telling this small system, subsystem, is not a finite element. It is another system. That means inside you will have something similar Like
Take
a
a
big
look,
system.
for example, on subsystem that is drawn on figure 1 in red color. On the next figure number 2, the big red circle is the small red circle from previous figure 1. You can see that inside this big red circle, there are again smaller colorful circles that represent subsystems inside this red system. So for example, if on previous figure 1, the big blue circle represented a computer, this big red circle on this figure number 2 represents processor inside computer, and subsystems on this figure represent, let's say, transistors and wires inside this processor.
Right. Now, I'll stop playing this one at this moment. You all can go through this link and can listen to this video, right? So it's really an interesting video, right? When you'll have time, just run through and understand what is system. Okay, basically what he's telling, system is having subsystems. Subsystems are interacting. The subsystems also, if you further look at it, also having some more subsystems, right? So you can go on and go on and go on, right? That is what it says. Now, the society is a subsystem. In this society, we have a lot of subsystems. So all these are interacting, and the outcome is coming not individually. So as a whole, so our all engineering creation is going to this system. So we have to understand the society. That is why, so we need to understand our role in the society. It is not purely an engineering decision. Okay? Everybody clear?
Please.
Right. Now, I'm giving you some few more concepts, right? This is really interesting, huh? So listen carefully. Right. This I extracted actually from this article. You all can copy paste this article in a Google Scholar. You can download this article. Huh? Otherwise, actually, I downloaded already the article. I can share with you all. Right now, this what is this called? This is scientific knowledge, right? So there is a confusion. There's a one common source of confusion, especially for those who are not engineer or scientists, is understanding difference between the engineering and science. Do you think engineering and science is same or different? Is that science and engineering same?
No, sir.
Right, yes. It is not the same. There are similarities, but in general, the science and engineering is not the same. What is science then? Science is primary aim to develop knowledge and understanding the physical universe. Listen carefully. Science is primarily aimed to develop knowledge and understanding of the physical universe. You understand different scenarios. Science is that. Therefore, scientific research, when you do a scientific research, often occurs without considering the social needs or implications. The atomic bomb. When they invented this one, so they didn't think about the implication to the society. It's a scientific invention, right? So this type of research often driven by curiosity. So you want to find What is inside? So why this is happening? Why when the apple is removing from the tree, why it is coming down? Why it is not going up? That is just science. But engineering is little different. What is the difference? This is the difference. Now, if you put it into the Venn diagram, this is our scientific knowledge. Can you all see? This is our scientific knowledge. This is our science. From this science, what we need, this is our social need. We need vehicles to go. We need vehicles to transport goods. It's our need. A scientific knowledge may be a wheel, a combustion engine, or a steam engine, or a battery. When the intersection between the scientific knowledge and the engineering and the social need is the engineering. Got my point?
Yes, sir.
Right? Now, this engineering is basically the use of scientific knowledge in order to fulfill the society need. Right? Now, what is the role of the engineer? Engineer's role to identify the scientific knowledge, gather the scientific knowledge, and do some hard work and make something useful to the society. So we are doing a very good job, very valuable thing. Yeah. The application of scientific knowledge, that is what we do. Now look at this. Analysis and creativity. Right? Now we'll try to identify this analogy. So what is creativity? What is analysis action of aspects of human activity? What do you mean by analysis? Any example? Now imagine we use a software to solve an engineering problem. What kind of a software? Let's imagine we want to identify in a building or in a one floor how the temperature changes in location to location based on the sunlight. So we use some kind of a software and we model it and we put it and we process. That is, we use this software to resolve this engineering problem. There is no creativity. There we use analytic knowledge. Yeah. So what is creativity? The creativity is something new. Let's say now you draw a picture, you write a story in general life examples. That is creativity. Now we'll put all these two Venn diagrams together. Now here we have the scientific knowledge. Here we have the social need. The intersection is engineering. in this engineering, again intersected by analysis and the creativity. Now we have identified sectors A, B, C, and 1, 2, 3. What is sector A? Anybody having an idea? What does it say? Sector A. It is part of scientific knowledge. It is part of social need, but it excludes the creativity, but it includes the analysis. What kind of thing can be it? It is basically sector A would involve using mathematical model and the computer simulations kind of a thing, right? So look at section B, sorry, section C. Here, it includes the scientific knowledge, it includes the societal need, it includes the creativity, but exclude the analysis. What is it? So that can be some creativity. For example, development of the iPhone, which combine the technological innovation with interface design. So that is a creative part of this. And what is B? It includes the scientific knowledge, social need, analysis, creativity, all. But again, think this is also engineering. So what kind of engineering is this? A completely a new thing. Okay. Got it or not?
What is it?
For an example, let's say now design of a electric vehicle is kind of thing. You have the creative knowledge, you have the analytical power, and you use the scientific knowledge, and it's a societal need, right? I will share the lecture notes with my notes. You all can see the sectors 1, 2, 3 also. I'm not going to discuss since we are running out of time. Yeah. So basically what we need to discuss is engineering. The engineering is basically from the scientific knowledge, we make something for the society need. That is our objective, the being an engineer. Now, there is something important concept that we need to look at is a global engineer. Now, okay. Imagine a musician. Is it a kind of a global thing or a local thing? The music. I think everybody would agree it's a global thing. Correct? Likewise, the engineer also a global. So wherever you go, the boundary conditions may vary, the difference, the climate may vary or different, but engineering practice, there are more similarities all over the world. Right? Some of the principles, even if you go to the moon also, the principles are same. The engineering will be same. Right? So because of that, to be a global engineer, we need to have some engineering skills. And other thing that we need to understand, we have to be a global engineer, but we should understand the local scenarios as well. That is why I from the beginning, I explained now some of the projects when we are doing in the local context, it may be difficult for you to do because there are some restrictions, there are some objections, there are some comments coming from the system, the society. We have to think of how people think, what is the people need, so what will happen to the environment, so what will happen to the society, what will happen to our culture, so whatever we design as an engineering project. So to be a global engineer, we need to have these kind of 6 skills. The one thing is the language, other one, so wherever the engineer should have the teamwork and the group dynamic skill, and engineer should have the knowledge and the knowledge of business and the knowledge of international variation in engineering education and practice. Read this extract. So I got it from one of the book, The Engineer and the Society. If you read this, the engineering profession faces severe challenges in basic technological problems whose solution involves the behavioral and social sciences and affects the very structure of the society. The engineering profession faces severe challenge. We have a challenge in technological problems whose solution involves, in our technological problems, when we are giving a solution, that solution involves behavior and the social sciences and affects the society. So what does this mean? This means the engineering profession, we are facing a big challenge in solving basic technological problem because it involves human behavior and the social issue and impacting the society structure. This means they need to integrate more knowledge from social and behavioral science, consider broad impact of their work on society. Understand? You can't just do your engineering creativity. So we have to think of society. What is this? This is spider web. Okay. If I am telling spiders and engineers are similar, spiders and engineers are similar, both challenges when designing structures. This part is really interesting, right? I will share the notes. You'll read, you will understand the spider's way of structure. Basically, this says, anybody just think of how the spider web work? Anybody just thought? When look at the nature, so how this spider web works? Can you all see the web in radial direction? This direction, in this radial direction, sorry, this direction is more tension. Correct? In this spiral direction, circular direction, it is sagging. It is not tension like the radial direction web. You know why? Anybody has an idea? Hello? All are with me?
Yes, sir.
I will share this one. You'll read. This is basically now when a flying insect comes, so even if the 1 or 2 radial direction thread broken down, so this can tolerate, so whatever the impact come from the flies or an insect, right? It partly absorbed by this radial direction and the circular direction threads, and it starts swing, and part of the pressure giving into the air because of the air resistance, right? Because of the air resistance, so this spider web is capable of absorbing the pressure coming from this flying insect. It is explained here. The similar way we are designing the building structures as well, right? There is another important concept that I want to share with you all, is an engineer imagines. Now, so far what we have discussed is mainly one thing. We should understand all our engineering creatives are for the society. How engineering creativity comes or production comes from engineering science. When engineering science intersects with societal need, we do the engineering creation or innovation, right? Can you remember? This is the point. Scientific knowledge or engineering science and the societal need. So we do engineering creation. And we discuss about a system. There is a system theory. The system theory discuss about subsystems and the interaction of subsystems, their input, their output, their interactions, right? The society is also like a system. So whatever the things that we are producing to the society, it has to be useful. We have to not only think about the technological part, we have to think about the social, cultural, environmental, all these factors. Now, and we discuss about the global engineering skills, right? Now we'll look at this concept called an engineer imagines. Anybody heard about architect engineer? This engineer is Peter Rice. I extracted this part from one of his autobiography. He's telling, I am an engineer. Often people will call me an architect engineer as a compliment. Just some people will call me an architect engineer. It is meant to signify a quality of engineer who is more imaginative and design oriented than the normal engineer. Now, what I want to tell you is this actually. Now, this gentleman is a good structural engineer. He is capable of designing many structures. This is one of the structure he designed in Australia, right? What is this? Sydney Opera House. Yeah. Not only this, he has designed very, very eye-catching designs. Now, because of this, his creativity, sometimes people call he's an architect engineer. That is because he is making some creation. But what he is telling here, it is a misconception. All the engineers are creative. All the engineers are creating something new to the society. Got my point? So all your decisions, imagine you are working in a, let's say in a factory, you take some decision, it has some creation. Let's say you are in a building construction project, you take some decision, it has some creation. So engineers, being engineers, you have to have imaginations in order to do all these creativities, right? So we have to practice. We should not go in the same path that other professions go in. We have to have this imagination. Yeah. Here, actually, some different type of engineering roles in different engineering fields I have listed out and their contributions. So you all can understand these things. No need of going through the discussing. Correct? Now, if you look at civil engineering, so what are the roles? You have to design, you have to oversee construction, right? So what's the contribution to the society? Right? Can you all read it and understand?
Yes, sir.
Yeah, these are very simple thing. Huh? So, I mean, just to understand different roles. I mean, being electrical engineer, mechanical engineer, or electromechanical engineer, right? Software engineer, what you can do. I want to tell you all new perspective. You know, okay. You all know about Industry 4.0? Heard about Industry 4.0?
No, sir.
Right. Right. Okay. Industry 4.0 is a use of technology and connecting all IT part in order to increase the efficiencies. That is basically doing in manufacturing sector. Right? You'll just browse Industry 4.0. You will get a lot of YouTube videos and articles, right? I mean, take some simple thing, you will understand. Not big thing, right? Now, this Industry 4.0, now we are using for the betterment of the society. So now, this phenomenon we call Society 5.0. Now, I have given some example here we will discuss. This Society 5.0 is used mostly in Japan nowadays, right? That is the use of Industry 4.0 and the other part of world also. Now, we now in this PowerPoint slide, now I'm explaining a historical perspective on engineering and social development, societal development. We all discuss about the hunting era, then the agriculture society, agrarian society, then the industrial society, then information society. The last one, the latest one, now we talk about the super smart society, that is society 5.0. This is, we call the hunting era, we call society 1.0. Then the agriculture era, we call the society 2.0, just given a names, right? Then industrial era, we call the society 3.0. And the information era, we call society 4.0. Now, the society 5.0 is actually use of this industry 4.0 IoT. You know IoT? What is IoT? Internet of Things. You connect everything, right? This industry 4.0 you are using for the betterment of the society, that you call the society 5.0. You know what is the SDGs? Sustainable Development Goals. Yeah. So you look at how the industry 4.0 can be used to achieve the sustainable development goals of the society. That is, you call the society 5.0. Here, industry 4.0, you use it here. It is called the society 5.0. Here it is explained. Look at this. Industry 4.0 promises to revolutionize the industrial production with increased operational efficiency, the development of a new business models, services, and products. It enables real-time production planning and dynamic optimization in contrast to the conventional forecast. This is limited to industry. What is Society 5.0? It focuses on the use of these tools and technologies developed by Industry 4.0 to benefit of a humankind. Right? This is just a comparison of Industry 4.0 and 5.0. This is very, very, very important concept, right? So the engineer's role is there. So how engineers using this scientific knowledge to make creativity, to creative thing, being engineers, the engineering products, and then not limiting to the industry. So how the engineers use this knowledge into the society for the betterment of the society. So this part is explained. So, I mean, but anyway, we will look at another video. This will give you all.
In Japan, innovation.
Can you all see the screen, the video screen?
Yes, sir.
Right. See whether can you all hear? Can you all hear?
Yes, sir. Yes, sir. We can hear.
Right, right. Okay. Listen to this carefully. This is a very simple, short video, right? There are enough videos available in YouTube. Look at what is Industry 4.0, what is Society 5.0. So this is our role, being engineers, right? Listen to this.
In Japan, innovation has been transforming our society, in which people can extend human ability. For example, a technology which improves our performance. With new wearable interfaces which analyze wearers' movement using AI and accumulate the techniques of great performers as electrical stimuli, wearers may play like great performers due to the stimuli sent by interfaces to wearers' muscles. Telexistence technology realizes our own avatar robots in practical use, enabling us to see, hear, and feel beyond time and distance as though we were there. Assistive suits, which read wearers' wills by receiving biological signals sent from the brain to the muscles, support users' heavy lifting work. The suits reduce the user's burden and let us handle heavy work much more safely and comfortably. Advanced technology will support a variety of activities and improve our lifestyles. Japan aims at realizing Society 5.0, a technology-based, human-centered society.
Now, did you all notice now a young lady cannot lift the heavy weight, right? Now, this technology supporting her to carry heavy weight by some instruments, right? Similarly, now many of the cities in Japan, they try to use autonomous vehicle without a driver, so you use vehicles. They are using whatever the available technology for the betterments of the society. Right? So I want to now we will wind it up. Right? Now I want to give a message. Right? This is my message. Youngsters as engineers are the people who can transform the nation. Right? You all are very young, right? You all have the opportunity to transform this nation. Being young engineers, right? What society expect is that. Understood? So you know this Abdul Kalam. You know Mark Zuckerberg. You know why Abdul Kalam is called the missile agent? Anybody knows? Any idea? Hello?
No, sir.
Abdul Kalam has given a lot of input in missile designs. So I also got to know, I mean, so when browsing internet and searching various things, I all of a sudden found this guy. So he has given a lot of things in missile engineering. Mark Zuckerberg, of course, everybody knows, right? But I mean, being young engineers, you all need to be somebody like this, right? So now, my message today, right? What we are studying is actually the engineer. So what is our role in society? The first thing, if you sum up, we need to understand what is society. Society is a system. in this system, there are many components. Those components, the one component, people, environment, cultures, and some other technologies, right? So all these components are connecting to each other. So when we are doing some creation, so it impacts this society. So our creativity should be for the betterment of the society. So we have a lot of avenue. For example, the industry 5.0, sorry, the society 5.0, where we are using a lot of technologies for the betterment of the society. Now, we have this opportunity, right, to use more technological thing and improve our society. That is what we expect from our young engineers. Here, I'm sharing you all. I will share this article, correct? This article explain about the Japanese concept for super intelligent society or society 5.0, right? Read this article just to understand what engineer can do to the society, right? And we are meeting next time. When is it? On next weekend?
Yes, sir.
Next weekend, next Sunday, correct?
Yes, sir. At the moment, we only have one session.
Only have one session. What do you mean?
Only in the Sunday, sir.
Only Sunday. Yeah, right. Okay. Now, next week, we need to look at engineering decision, right? I'm going to discuss with you all. This is one of the non-technical aspects of engineering. I told you all, I mean, basically, there are a lot of tools. The one thing you can use actually net present value, the payback period, discounted payback period, right? I can't discuss in detail all these things, but I will tell you all. And I mean, using internet and using YouTube and using some textbooks, you all can further learn. I'm sure that there must be some modules or outside, so you all can do some financial subjects, right? So I mean, there are a lot of way of gathering this knowledge. So next week, actually, while introducing those kind of things, we will basically discuss about decision-making process. It is called analytic hierarchy process. You all can see the screen, huh?
Yes, sir, we can see.
Yeah. So this analytic hierarchy process, why I want to discuss this one, because when things are complicated, I mean, when you have a lot of options, when you want to compare many things, if it is anything more than 6, actually the human mind can't compare. So if something very complex, so how we are going to make decisions? This is called the analytic hierarchy process. So otherwise, I mean, there are a lot of ways of, I mean, the taking decision matrix, or you know that SWOT analysis, right? Those are, I mean, the decision trees, right? The cost benefit analysis and the Pareto analysis, right? So, but we will discuss in detail this method, analytic hierarchy process, right? This will be very useful being an engineer when you are taking decision other than the engineering, right? Whether to do a project or not. Let's say now you want to decide decision on selecting university. So how we are going to take decision, right? And after that, actually, in another lecture, we will discuss about engineering ethics, right? So this lecture not, in fact, I need to develop further. There is another one, actually, I started developing, that will be really interesting, the communication, right? So we will discuss some of the theories also. This will be really interesting, right? And yeah, okay. So I think today what we discuss basically, I mean, you don't want to take very serious, but conceptually, we need to understand that engineer play a role in the society. So other than the engineering technical aspects, we need to look at other aspects, because in this society, there are other systems. The environmental aspects, the social aspects, cultural aspects, all these things we need to look at, because all these are influencing each other, right? So that's the summary of what we did today. Is it clear? Clear for everybody?
Yes.
Right. So,
Yes.
so how you feel? I mean, this the first lecture, is it kind of too much talking or boring, or I need to give more times to think, or what? What do you think? So that I can arrange next couple of discussions in a different way. I like, actually, if you all are giving answers, whether it is right or wrong, or I mean, so whatever the feedback is really important to make this discussion live. Because we have only 12 or 13. We have only 13. Yeah, including myself. So it's not a big crowd. Yeah. Okay. Can
It's a
any of
very,
you?
very,
Yes.
very interesting. So we hear a lot of stories that we have never heard of.
Yes, there are a lot of things, right? I mean, just don't wait, right? When you have free time, you all browse internet and see what is Industry 4.0, what is Society 5.0, right? And listen to that system theory video, right? There are a lot of videos, actually. No need to look at everything. You look at a couple of things, then you will understand. So that's it. Okay. All right.
Okay, sir.
Right. Then we will meet next weekend. In between, I will share these notes. And I thought that, actually, so before we discuss, to share the PowerPoint slides, so that you all can have a printout if you all want to make some notes or something like that. How can I share the information? I mean, the slides and some of the articles that I have downloaded for you all to read. How can I share? Is there a
Through LMS.
You can upload it in LMS.
I can upload it here in the system. You all can download, correct?
Yeah, yes, sir.
Right. Okay. I'll do it. Right. Okay. Thank you so much then.
This video.
Sorry, dear.
Can you upload this session also, video session?
All right. Right. I'll do it. So I'll do it. Right. Okay. Thank you so much. Good night then.
Thank you, sir. Good night.